Hi everyone, and welcome to our webinar, The Roadmap to AIOps, The Next Steps. I'm Monica Brink in the Solutions Marketing team here at BMC, focused on IT operations management broadly and AIOps in particular. So this topic is a continuation of last month's webinar and part of our ongoing AIOps webinar series. So thank you for joining. Before we get started, just a couple of items I want to remind you of. There is a Q&A box there on the left-hand side of your screen. So feel free to ask us any questions. We'll try to address those as we go throughout the webinar or at the end. Any that we don't get time to address, we will follow up with you afterwards. We'll also be having a series of polls throughout the webinar where we'll be asking for your input on where your organization is at in terms of different AIOps capabilities and planning. So please encourage you to get involved in those polls. It's a good opportunity to see what your peers are doing. And there's also a resources section there on your webinar screen to the right where we've posted a number of different resources you can access to learn more. So with that, I want to introduce my co-presenter today, Seth Paskin. Good morning, Seth.
Good morning, Monica.
Can you tell, for those listeners who haven't had the opportunity to have a webinar with you, can you tell us a little bit about yourself and your role at BMC?
Sure. So I've been in IT for in excess of 20 years now in a variety of different roles. I've been on the engineering side of the house, and I've been on the services side of the house, and I've also been on the marketing side of the house. Currently at BMC, I'm Director of Technical Marketing for our performance and capacity management and so on, our AIOps type solutions. That's a pretty broad portfolio, and it's kind of my responsibility to help educate our customers and prospects about how we implement machine learning and analytics in our products, as well as my team making sure that we can demonstrate that and to folks as well.
Okay, great, thank you. And on our last webinar, you were in the midst of planning an Italian vacation, which I believe you're actually departing for tomorrow, is that right?
That is correct. In less than 36 hours, I will be on a flight to Italy. So I changed my date just to make sure I could be here for this webinar. I'm kidding, of course.
Oh.
It just worked out. It just worked out that way. But I'm very excited. And on the last webinar, some of the attendees gave me some great suggestions about things to do and see while we were there. So if anybody on the call wants to share any Rome or Venice tips while we're doing the presentation, I'd happy to take them.
Yeah, absolutely. Well, that sounds wonderful. I'm sure you'll have no shortage of things to see and do in that beautiful country. All right, let's get started here. Before Seth dives into some of those next steps on the AIOps roadmap, we wanted to start off by pointing you to the Gartner approach to AIOps. It is represented in their market guide to AIOps platforms. Now, we do actually have this Gartner report available for you to download in the resources section, so take advantage of that if you haven't had a chance to read it yet. There's a definition of AIOps there, which I won't spend a lot of time on because I think most of our listeners are aware of what AIOps is, really a new strategy for IT operations teams to apply analytics and machine learning into their existing processes and tools. Now, this is a good intro to the content of our webinar because Gartner points out the key aspects of AIOps, starting with ingesting that huge volumes and variety of operational data into a big data platform, monitoring and filtering that data, applying machine learning, and then also engaging the service desk for required actions and having automated actions coming out of those deep insights that AIOps delivers. And a key part there of that Gartner AIOps wheel that's represented on the slide is the analytics frameworks that need to be applied to enable these AIOps use cases. So Gartner identifies those that are at a high level, some of them including historical analysis, anomaly detection, correlation and contextualization. So in this webinar, we're going to go deeper under the covers of those analytical frameworks and just explore in more detail how they support these AIOps use cases and what really you need to know to start to include them in your AIOps strategy roadmap and your planning. So with that, I'm going to pass it over to Seth for an overview of the roadmap.
Great. Thank you, Monica. So I won't spend too much time on this. I'll encourage anybody who wasn't with us for the webinar last month. We covered essentially the first 4 steps of the roadmap, and I'll just summarize it this way. We talked about the importance of making sure that you are aligning your IT use cases and metrics, KPIs, to business initiatives. So in other words, making a clear and explicit connection to the business goals. And then once you make a clear connection between what's going on in your IT environment to how you're driving business outcomes, whether it's cost reduction, growth, revenue, whatever the case may be, then you can start defining success criteria against those specific KPIs and start setting goals for your AIOps initiatives. Because if you don't have a very concrete and specific measurable outcome that you're trying to drive, you can't use analytics and machine learning. So we talked about that, and then we just talked about looking at, once you understand what you're trying to accomplish and where you're going to put your efforts, understanding what the data is doing, the data you need, where does it sit, is it siloed, is it together, do you need to pull it together, how accessible is it, how frequently can you get at it, so on and so forth, and making sure that you create systems of record to start tracking your progress, particularly with respect to being able to report out to executives or whoever might be either interested in the outcome, stakeholders, or funding your project. So taking that as the jumping off point for this webinar, we're going to talk now about implementing analytics workflows. Really, this is going to be about taking the next step into understanding what your data is going to be doing when you start doing analytics and machine learning on it. I'm going to talk specifically about 3 different types of machine learning algorithms that are very common in IT operations and explain to you at a high level how they actually work and what types of things they can accomplish for IT operations. Then we'll go on and we'll talk a little bit about automation as a practice and as a culture that you can start implementing in parallel with your AIOps analytics and machine learning initiatives. And then we'll wrap it up talking about once you've got some momentum going on the initial implementation of your AIOps strategies, what can you expect to find and to do, and what sorts of changes might you need to do in the skill sets and in your organization, your personnel, and in the team. Okie doke. So let's go ahead and march forward. In this section, I'm going to talk very specifically in just a minute about 3 particular analytics workflows. This is really, I should say, machine learning algorithms. That's a bit of a misnomer there. The 3 are called regression, classification, and clustering. So I'm going to actually spend a little bit of time on each one, and we're going to talk specifically about what they are. But before I do that, I just want to make one point. We at BMC have a strong commitment to the notion of service and application modeling in the IT environment. And even as you move into your AIOps initiatives, the idea that you take a look at your business from a service or a business perspective or an application perspective versus an infrastructure perspective, it still has validity. So we want to make sure that you're not essentially thinking that analytics and machine learning are somehow going to replace some traditional disciplines inside of IT management. They augment and expand, but you're not essentially swapping out wholesale what you used to do for some kind of new methodology. And to that same point, the rule-based approach, which we've been doing for 15 or 20 years or 30 years, however long it's been now, rule-based approaches don't scale. We know that. We know that you can't keep up with the sheer volume and velocity of the data with manual setting of rules. That's absolutely true. However, rules do encapsulate domain knowledge and sometimes specific knowledge that's in other people's heads. And that knowledge is still very useful for context in putting together your analytics and doing things like supervised machine learning and so on and so forth. So the net of is I just want to say, you're not throwing the baby out with the bathwater. You're going to continue to do the things that you've been doing. You will be able to scale against the changes in the environment better with analytics, machine learning, and automation. But you shouldn't expect that that's somehow a panacea or a replacement. If you don't have good discipline right now, around approach that looks at your IT environment from a business perspective, as opposed to, or if you don't know what good looks like right now in your environment, you're going to struggle to be able to implement the analytics and machine learning. So I'm just saying, respect the investment that you've already put in those disciplines and the knowledge you've built, because it will be the foundation upon which you can move forward. Okay, Monica, I think you wanted to do a quick poll before we went on.
Yeah, that brings us to the first poll, which covers your point you just made there, Seth, around continuing to have that discipline and importance in terms of application and service models as more and more IT organizations branch into AIOps. So take a moment to respond to this poll. Are you currently actively using service and application models in your ITOM environment? We have 3 choices there: yes, in some cases, and no. I think quite broadly, Seth, I would say that the majority of our customers do have this practice in place, because of our focus on that in terms of ITOM best practices. But, I think you make a good point that in terms of AIOps, it's not a panacea for having that strong foundation of rules and service models in place.
Yeah, absolutely. And one of the other reasons I mention it, Monica, is that as we see a shift in paradigm from, to this notion of tagging and just the way in which infrastructure is code and the way that the CI/CD pipelines work, the application models themselves, or the service models themselves, and essentially the relationships between elements that make up a modeling, are becoming encoded as part of the infrastructure, and that also can turn into a data source that you can leverage in your analytics. The analytics will be able to understand, because it's not metadata, but it's actually data that's part of the model itself that can be used by the analytics. So it's another reason why it's important.
Okay, yeah, that's a great point. So let's take a look here at the results. Okay, interesting. So we have around 19% yes, 55% in some cases, and 26% no. Is that what you would have expected, Seth?
Honestly, I would have thought we had been a little stronger, a little more representation at the top end, but I'm not too surprised otherwise. I think, as is the case in many complex IT environments, probably people put their energy where they can get the most benefit. So, we've heard stories that, in a general enterprise environment, of all the applications, maybe only 5 to 15% are actually monitored, because you just monitor your critical and your mission critical apps. So it's probably a similar kind of story here, where people are putting their energy into where it makes sense for them, because it is a huge undertaking to model an entire environment.
Right, and I'm sure with DevOps environments taking hold and IT ops teams experiencing faster application releases, that's challenging as well to keep those application service models in place.
Absolutely. All right, shall I jump forward?
Yeah, let's move on to I progressed, there we go. Supervised and unsupervised machine learning.
Okay, so I want to set the stage for our conversation about regression, classification, and clustering. It speaks specifically about supervised versus unsupervised machine learning. And I think there's a little bit of misconception. It's not a difficult concept to grasp, but I frequently am talking to folks, and they don't necessarily understand the difference. So there's the 2 different kinds of basic machine learning that are used for the majority of IT operations use cases, are supervised and unsupervised. And all that means is, in a supervised model, it means that you as the practitioner, you as the business owner, know what good looks like. So you're able to tell the machine that's doing the work what they should expect to see in the form of input data, and then also what that input data will result in, what the output data looks like. And what the machine does is it will actually take that data, it will look at the actual results, and then it will create what they call training and test sets, and it will try to come up with the algorithm that best fits the training data, and then apply it to the test set to validate it. And so this is the notion of the machine being trained. And so that's what's called supervised machine learning. So just supervised means you know what outcome you want to achieve, and you're training the machine to do it so that it can scale up and do it on new data that you haven't seen yet, or do it at a scale that you can't currently do manually. In the case of unsupervised machine learning, the way to think about that is where you have a mass of data, but you don't know what you're expecting to get out of it, right? You don't know what goal you're trying to achieve. You don't know what good looks like. And what the machine does then is it takes a look at the data itself, the structure and the actual data points that inputted, all properties and so forth, and it models and it learns from the data itself what kind of structure to do. So that's what's called unsupervised, because you're not training it; it's just doing it itself. And I wanted to make that distinction because I'm going to talk about them specifically when we talk about these specific algorithms that we have and what use cases, IT use cases, the different types of machine learning are good for. Okay, so let's talk about regression as our first machine learning algorithm. So regression is an approach that's designed to help you create a function that will describe or predict a continuous output variable from a set of input variables. So what is a continuous output variable? A continuous output variable just means it's usually a numeric value that's on a continuum. So for example, it could be a percentage anywhere from 0 to 100%. It could be just a count, like the number of users that are on a site or the number of errors that are being thrown or something like that. It can also be something fractional, like it could be a probability between 0 to 1 in fractions. But it doesn't have to be infinite. So in the case of 0 to 100%, there's a finite range. In the case of number of users, theoretically, I suppose it could be infinite. But the point is that your output can fall anywhere along a scale that's continuous, as opposed to being a specific set of values that you're selecting from. And usually you use this when you have data that's going to have a kind of contiguous shape that runs along one or more properties. And that property, in the case of IT operations, is almost always time, right? So you're looking time or a percentage. So for example, you might think of, if you look at the graph on the lower right that's kind of curvy, you might think of that as representing, for example, let's say some form of performance metric like CPU, memory usage, whatever, over time. And in the category in the upper right, you can imagine that on the bottom, you've got 0% to 100%, and you're looking at a projection for when some kind of value is going to reach 100%, or what sorts of inputs are going to generate a 100% value against that. So the way I think about this is I think about shape. In the case of regression, you're trying to find a way to develop a mathematical model that represents a shape that you see, kind of, that if you visualize it, looks like one of those two or something like one of those two on the right. And that mathematical model then will calculate how to best fit the shape based on the data that you've given it. And then it will create an equation which you can then put new data in, and it will predict, so to speak, the outcome of what that new data will generate in terms of outputs. And so in terms of AIOps use cases, you can see, especially consider the one in the upper right, that's great for forecasting saturation, forecasting when you're going to violate a threshold, right? Like at what point in time am I going to do this, or with what set of criteria occur should I expect to see this particular outcome? In the lower right, this is what you might think of more as your kind of dynamic baselining approach. So this is where you're forecasting what normal, quote unquote, normal looks like, what to expect. So if you imagine that this represents a day point in time, you might say, okay, at around noon, we're peaking out at 2, whatever that numerical value 2 means. And then, over the next 3 hours, it declines. So you can then create a model that says our expectation, give or take X amount of percent, is that we're going to be, at a value of 2 at noon and a value of 1 when we get closer to 3 or 4 in the afternoon. So that's kind of the typical sorts of AIOps use cases. Now, for those of you who are paying attention, you should realize that this is what we call supervised machine learning, because we're taking existing data, we're creating a model from it, a mathematical model, and then we're going to apply it to new data. Okay, hopefully that was clear. I think if we when we talk about classification here, you'll understand the difference, because it's very similar, but it's accomplishing a similar kind of task, but with a slightly different outcome. So when you think about classification, it's very similar to regression in the sense that you're creating a function that's supposed to describe the output or predict the output given a set of input variables that you know in advance, right? So you know the data that's going in, and you have some examples of the output, and you're trying to figure out what the relationship is, how you can model it. The difference between classification and regression is that in classification, you're not trying to get to a continuous output. It's not 0 to 100 or 0 to 1 or number of users. It's a discrete output. So it's a selection, if you will, from a finite set of alternatives. If you can think about it this way, you might be trying to describe just critical, medium severity and informational, or you might be trying to distinguish between what's abnormal versus what's normal, or what's spam versus what's not spam, or whether somebody will purchase something or whether they won't purchase it. Those are just simple examples, but any finite set of options, it could be 5, it could be 10 different outputs, it doesn't matter. You're basically trying to select between one of those. So because the output is different than that continuous model we talked about before, classification uses different mathematical algorithms underneath it. It's very much a similar kind of activity, it's just different math underneath. So the way I think about this is, instead of your data having a defined shape like regression does, where you're trying to fit to the shape, really what you have is a distribution. So if you look in the upper right, you see that there's a distribution. There's not really a shape to those data points up there, but you can see if you look at the green and the blue and the red, there's kind of a distribution using those colors that they kind of clump into into particular groups. So what you try to do with classification machine learning is you want to fit your data against the distribution for the properties that it has. In this case, that's a simple 2-dimensional model. So there's one property at the left-hand side and one on the bottom right. But you can do this for any number of properties. It becomes impossible to visualize it in a graph that we can read with our eyes. But even 10, 15, 100 different properties you can use, and there's math to help figure out what the distribution looks like. So the way I think about this is, if you look in the lower right where you see that colored map, right, you can think of that as a kind of a form of representation of the type of data set above. Those two are not identically related, but I'm just trying to give you a visual to make the point, is that what the algorithm is going to try to do is not come up with a mathematical model that's going to predict where something will be at a point in time along a shape, but instead we'll pick where it's going to fall inside of the distribution that you've modeled. Now, what is this good for? This is also useful in IT operations for doing forecasting. So, for example, if you're trying to anticipate where what kind of outputs you're going to get with respect to a certain set of inputs, it could be any number of things. It could be what kind of performance are you going to get if you put these inputs in place? What sorts of things are going to impact, right? You can add data. You can use it for data enrichment because you can classify things against properties that the data doesn't have, and you can add that to it. You can use this for simulations and what-if scenarios. So, for example, we use this in our capacity optimization tool to help you model if I add additional cores to the server, and if I do these kinds of changes, then what difference will I see, or what output will I get on this other end? So there's different use cases, and you can see it's just a question of the type of data you're working with versus regression. Again, those of you who are paying attention should realize that this is what we call supervised machine learning. You've got a known data set, and you're using it to train the system, and then you're using it to apply to new data. All right, so let's get to our last form of machine learning. It's called clustering. So clustering is similar to classification in that you're going to create groupings of data in a data set that doesn't necessarily have a defined shape that you might use regression on. But in the case of clustering, instead of using known inputs and known outputs to train the data set, to train the machine, you're going to use data that's inherent you're going to use characteristics of the data that are inherent to the data themselves. So there is a distribution, but the distribution is against properties that you don't know. So in the case of classification, you know the properties you're working with, and you know how that impacts the distribution. You want to train the system to find the most optimal way of modeling that. In the case of clustering, you don't know what you're looking for in advance. So what the machine learning algorithms do is they go in and there are many different techniques, but essentially they go in and they start to look at the data and start to logically group the data by different types of, based on different characteristics of different data. And then usually there's an iterative process to refine that to create the optimal distribution amongst the data set. So this is a very common technique for use, especially with logs and events. So it disambiguates unstructured data. So for example, if you have a giant clump, what we call a data blob, right? And logs are typically that. You don't necessarily know what's in the data, what's in the log, so you're going to use an algorithm like this to disambiguate it. It also works to surface and identify hidden relationships in data. So I think this is probably where you're seeing most of the application in the current era in events. You're going to see a lot of application meant to try to pull hidden relationships out of event data that's occurring in a complex system to be able to create relationship models so that you can do, probable cause analysis and things like that more efficiently. All right, so I've covered the three major machine learning types that are sort of at the root of most IT operations analytics, and I'll come back and be happy to answer any questions I can once we towards the end of the presentation. But I wanted to just kind of recap on understanding the implications and kind of what you're doing with these different machine learning algorithms and how they impact your environment. So in the case of regression, it's very frequently, not always, but most frequently applied to time series data, or at least data that has a time element in it. And based on using it for forecasting and for defining normalities and setting thresholds and so forth, what you use regression for is anomaly detection, right? It can help you do event noise reduction, and it can help you do forecasting. Classification is better when you have structured or semi-structured data like events, and particularly ones that you have known outcomes for, and then you're able to do things. Again, it will also contribute to event noise reduction, and it allows you to do simulation and what-if scenarios as well. And then finally, clustering as an algorithm is very good for unstructured data. The most common use case is log analytics, or really any type of analytics on large amounts of complex data that can be unstructured. All right, so hopefully that was a little bit enlightening. Like I said, I'll be happy to hit some questions here in a short while, but I think, Monica, you want to move on to our next poll.
Yeah, let's move on to the next poll. And this is a question around, are you currently investigating machine learning techniques like those ones just presented by Seth to support your AIOps initiatives? So we're really trying to dig into here how far along you are in identifying what those machine learning or algorithms or analytical workflows will need to be to drive your AIOps priorities. And I think if I recall, Seth, from the poll we had on the last webinar, did show that many were at the stage of identifying AIOps use cases. So I wouldn't be surprised if we're not too many in the audience today are actively identifying, at this point of identifying the analytical workflows and techniques.
No, I think you're right. My expectation for this is that we're going to come out heavily towards the bottom, if you will, that people are focused, in general, it feels like customers and the market itself are focused on the use cases. Right now, we probably have a few customers who are looking into the machine learning techniques themselves. Really, of course, we're going to advocate that customers partner with AIOps vendors like BMC to let us do the heavy lifting and implement the machine learning algorithms. But there are customers out there who are trying to build practices themselves, and we want to make sure we're speaking to them as well.
Sure.
And then of course we'll talk a little bit about the changing need for skill sets and so forth a little bit later on today.
Okay, let's have a look at the results. All right, so a fairly even split. It looks like we have some that are maybe a little more mature in their AIOps approach on the webinar today, so that's great.
Yeah, well, color me impressed. Congratulations to everybody for the level of maturity and advanced investigation. All right.
Yeah. Okay. So Seth sort of gave an intro there on the analytical workflows, and with our AIOps approach at BMC, with our TrueSight AIOps platform, we identify use cases that really respond to our customers' problems and goals as they undertake an AIOps strategy. So here's some examples of how the analytic workflows and different algorithms can be applied to AIOps use cases. And really, overall, the goal of the analytics effort is the discovery of patterns, both looking forward in time to predict potential incidents and service impact, and also looking backward in time to determine the root cause of current events. So a key one is event noise reduction, which we talk about a lot and is certainly a goal of many IT ops teams. So being able to deploy those classification and different types of regression analysis techniques to enable behavioral learning of that historical and real-time performance data to establish dynamic baselines and suppress any events that fall within those. And importantly there, that flows into predictive alerting as well, being able to avoid downtime using regression analysis of time series data to detect trends and patterns. On the probable cause analysis side, again, a big issue that many customers face, being able to drill quickly into the likely cause of any incident across millions of monitoring data points. So the clustering and analyzing and correlating of that unstructured data that Seth talked about, such as logs, to troubleshoot and determine probable cause becomes very important in this use case, and with the overall goal of speeding mean time to repair. And then capacity forecasting. More and more IT ops teams are working with their capacity counterparts, or often they're actually within the same team these days, to ensure there's that right sizing of IT resources that are invested in with business demand. So applying the regression and classification methods to forecast resource usage, simulate migrations across different platforms, whether it's on-prem or cloud or multi-cloud, and predict cost impacts. So some important machine learning and analytics algorithms at play there. So overall, we aim to demystify AIOps for our customers, and this is the approach that we find really works, starting with the problem and the use case of AIOps, and then applying those analytical workflows and algorithms to that. So just a little more detail there on how that is applied with our TrueSight solution. So with that, I'm going to hand back to you, Seth, for the next step on the roadmap.
Sure, thank you. All right, so let's talk about automation. So, I struggle with conversations oftentimes with customers around automation, just because there just seems to be we've talked about IT automation from a tool perspective and from an orchestration, sort of automating processes versus automating tasks for decades now. And I think people have been sold the promise of automation, and it hasn't delivered, or we've got piecemeal. We're good at automating tasks, and we're not necessarily good at automating processes. So I feel like people, there's a sort of a negative taste in people's mouth about the concept of automation. And what I'm going to hope to do in the next 5 or so minutes is kind of remove a little bit of that friction and give you a way to think about automation in the environment that makes it, recognizable and achievable, and that you become sort of more hopeful and optimistic about being able to really tackle this and break it down into component parts and address it. So to do that, I'm going to talk about different types of automation across what I'll call the automation value chain. So, I'm now looking at this. I want you to focus first at the top part in the box in red, right? So when you think about what's going on happen right now, right? So manual approach. And you're thinking about, let's just start at the beginning of the automation value chain with machine learning and analytics. Well, you have to pull data, and you have to run data, you have to do the analysis on it, and then you got to figure out what that means. You have to document it somewhere, and you have to make some kind of a response to it. So when you're doing that from a manual way, the application of analytics, you're doing that offline, right? You're pulling data, you're doing an ETL, you've got a separate data store maybe because you can't impact your production data store. You've got individual people doing short, small term types of analytics. And you're probably just, putting your finger in the dam, as it were, right? Then if you're asking those people to actually make notes and document things, and you're doing it manually, you're going to get an ad hoc documentation process where things that you learn may or may not get recorded. Changes that you make to your environment may or may not get recorded. Even in this day and age, folks, 90% of issues in IT environments are caused by undocumented changes and documented changes. So we know that that's still a problem, right? And then if you think about trying to understand what's coming out of the information, right? So if you're trying to react manually to issues in the environment, a manual approach means you've got a war room. We're all familiar with, there's an issue and you get 50 people on the phone and you're trying to figure out who's responsible and where the problem lies, right? All of this, because you don't have enough information. All you have is dashboards turning red. Everybody's got their own data source, and you're trying to figure out what's actually impacting what. And then, of course, if you're still doing manual response, you're talking about, okay, we figured out what the problem is finally, so we're going to send somebody out there to fix it. We're going to reboot this. We're going to patch this. We're going to do this. Oftentimes that can happen, and it's not necessarily recorded and verified, right? So I'm painting a picture of like a worst case scenario, which I'm sure nobody on the phone or nobody who's listening today is experiencing. But if you're thinking about automation and a culture of automation and an automation value chain, I want to talk about what automation means then at each one of those steps and how it can essentially drive value for you. So don't think about automation in terms of automating tools and processes like that. Let's talk about what does automation actually mean when broken down into these individual components, right? So if you look at the bottom in the blue, what would it mean to have automation as part of your, let's call it machine learning or analytics culture? Well, what it would mean is instead of you doing analysis manually, you would have the application of analytics and machine learning automatically on your data as it flows into your system. You wouldn't have to pull any reports. You wouldn't have to maintain a data store. I mean, you still might do that for some use cases, but the idea is you would be doing it as data comes in on your production system, where you would have the machine automatically applying the analytics to it. You would not be doing it ad hoc or as needed. And this would allow you to be applying those analytics in real time, which means changing your response from offline to online real-time response. That's one way that you can create automation in your environment. The second way you can create automation in the environment and the value you'll get out of it is instead of ad hoc relying on people to do documentation to do recording, to do ticketing, right? You could essentially connect your monitoring systems, your performance management, and your analytics system to a system of record. We talked about this in the last webinar, but I'm a huge proponent of this. I really, truly believe that every enterprise IT shop should have their service desk and their ITOM environment connected, and it should be automated where the ITOM environment, based on whatever business rules make sense, whatever business criteria make sense, make sure that the ITOM environment is creating tickets that can be plugged into the appropriate workflow, and you get an automated virtuous circle between your service desk and your ITOM environment. By the way, Gartner's showing you in the slide that Monica showed you at the beginning that service desk and the ITOM environment, having them connected is a critical success criteria for AIOps. That's what's represented here in the second bullet. Then once you have that in place, you can actually implement automation that allows you to enrich and update, essentially do forensics on the tickets and on the data before it has to go in front of any human eyes, and perhaps doing enough data enrichment that it never has to go in front of human eyes. So, on one hand, you throw an event from some sort of, again, let's talk just an ITOM event. You might throw an event from a piece of infrastructure. Well, if you have a service model or business model, then at least you know what the service impact of that event is. You know what the downstream and upstream connectors relationships are to that piece of infrastructure that are going to be impacted. Then if you are able to pull data from your discovery and, or your CMDB and update that ticket, understand the CI, the owner, right, any of the characteristics of that, if you have the ability to go query that asset, either you have a catalog somewhere that shows all the latest patches, versions, and so forth. Last time a change was applied to it, you can enrich the ticket with that. And you may, before, in a matter of seconds or minutes before it even has to get to a review stage, you may have been able to identify, hey, we had no problem with this asset yesterday. A change was applied last night. Now there's a problem. The machine says 90% of the time, I know that changes cause problems, so what we need is a rollback on that change. And at that point, you've got literally no manual investigation, but you've already got a proposed solution that the system has essentially given to you by virtue of your virtuous automation cycle. And then, of course, thinking in terms of response, yes, we all know about being able to set up, runbook workflows or automated response workflows, but the virtue of that is oftentimes underestimated is that when you do that, you can actually put in a closed loop process around it. So it's not just that you automate the response, you go and you redo the patch or apply a patch or whatever the case may be. It's that you can audit that it was done successfully, you can validate it, you can verify it, and then you can write that back to your system of record. So it becomes a circle where it's not just about doing everything in an automated fashion, but it's about how automation enables you to increase the speed at which you respond, but also increase the completeness with which you document, validate, and verify what you're doing. And it becomes, essentially by default recorded. So then when it comes time for auditing, reporting out, right, and of course reporting and on top of all of this is really critical, automation provides that value as well. So what I'd like to kind of put to you in this context is really about, think about automation in terms of the value it provides at every stage of the journey, at every point inside of your environment, and then think about how you can undertake automation initiatives that work in conjunction with your machine learning and analytics initiatives, and that automation and the machine learning, the big data approach, all that is all part of the AIOps story, right? So don't forget about automation in the AIOps context. All right. So I'm going to close up now, and I'll try to get through this so we have time for questions, because I'm sure we've had a few. So I just want to talk about what's the implication. Let's say you've implemented some analytics and some machine learning workflows. You've got some automation projects underway, and you're asking yourself, okay, what's next? Where am I going to head next? What's the implication for my team? Well, at a high level, I think what's going to happen, or what you should think about, is how your environment's going to evolve. As you start having successes in implementing machine learning for specific use cases, what's going to happen is people who are business partners of yours are going to see the successes, and they're going to ask you to do the same thing for them. I guarantee you that will happen. You will also see other instances where you can expand your existing use cases to similar or identical data sets in different types of pieces of your infrastructure. So that's the first thing. But you're also going to start seeing that once you conquer a certain domain, let's say you conquer your performance management piece and you say, okay, I'm ready to go on and tackle events, I'm ready to go on and tackle logs, right? You're going to bring on new data sources, which will bring up the opportunity to take new analytics and machine learning approaches. The second thing is once you start generating analytics and machine learning data, that itself becomes data that you can act on. So in other words, you can actually start doing analysis of the metadata that's generated out of your system. So you're going to start taking a second order view of your environment, and you're going to start saying, how effective is that algorithm working for me? How effective is the machine? How effective is this approach? How effective are we at managing our business service now that we've implemented 3 or 4 different machine learning pieces across our value chain? You know, what have we done to improve the performance of our business service, right? And then what that's going to lead you to is the ability to actually refine the application of things, but also it's going to go back and you're going to start seeing, oh, wow, you know, the way we currently have our application structured, the way data flows in our application, the way we have partitioned pieces of the infrastructure in the cloud and the data center across multiple clouds, whatever it is, you know, we've actually identified we have a bottleneck in this piece. We didn't realize it. Maybe we have a bottleneck because we've got, you know, we went to platform as a service and we've got, you know, we're using hosted SQL, and when we had it on premise, we were getting better performance or different performance, but we didn't know that that was the problem until we got to this point. So it's going to be just continually consuming more and more simple first-order use cases. You're going to start generating what I'll call second-order use cases, and that in turn is going to allow you to refine and improve your overall environment. It's also going to change the way that you implement new workflows, new applications. Could change your relationships. It's going to change the relationships between IT operations and the DevOps teams in the lines of business, for example. But the implication then long term, and I mentioned this earlier, is the IT operator as a discipline, as a person, as a role. For decades, that person's job has been to collect and to have domain knowledge of the environment and to understand how to remediate issues when they occur. It's been essentially, you know, it's of course about forecasting, you know, in terms of planning for infrastructure growth. It's about, you know, being the gatekeeper in the past for provisioning IT resources. But, you know, those roles are all going away, right? As cloud resources get consumed directly by developers, you know, and as we see these shifts in the way that platform as a service, infrastructure as a service, software as a service, the IT operator as a person has to become less of a doer. It's not your job. It's not going to be your job in the AIOps world to make the changes, to do the things, because the system is going to be doing that for you. If you're automated and you have the right, you know, machine learning and analytics approaches in place, you're supposed to be offloading the manual work. You're not supposed to be doing those things anymore. But what you are supposed to be doing, and what you will need to be able to do, is you're going to have to make sure the system is doing what it should be doing. You're going to have to be an auditor. And to do that, it's going to require that you maintain your knowledge of what's good in the environment. I talked about supervised machine learning. You still are responsible for knowing what good looks like in your environment, for understanding how your environment works. But you're going to have to at least get to a business level understanding of, for example, what I talked about today, understanding what regression, classification, clustering, in the future, the new things that come on. You're going to have to be able to have a meaningful conversation either with somebody in your organization who's developing those, or, you know, in our world, in the BMC view, more ideally, somebody like us, a vendor, where you can say to the vendor, look, these are the business outcomes I'm trying to achieve. I'd like you to tell me, how do you achieve those business outcomes with machine learning and your tools? And then when I have a conversation with you and I say, well, here's what we do. We use regression, we do this, we do performance management this way, we do event management this way, we do log analytics this way, we do probable cause analysis this way, then you can, have that level of confidence in your understanding of the techniques to be able to say, you understand and you have confidence, you're able to trust that our solution can actually achieve the outcomes that you're looking for. So that's how I see the evolution in the space. All right, so I think we wanted to get to our last poll and close it out here, Monica.
Yeah, following on from that discussion on skill sets, has your IT organization started to evaluate and implement the new skill sets required to execute on your AIOps strategy? Just take a moment here for you to respond to that one. And I would guesstimate, Seth, that the spread of answers here would be similar to our previous poll, that if some of the IT ops leaders on the phone on the webinar have been looking at regression and classification and clustering and other algorithm techniques, that they will also be starting to look at the different skill sets that they may require.
I think you're right. Had I not seen the previous poll, I would have guessed that, again, we would have been a little bottom heavy on the responses on this one, but I'm going to predict that you're right. I think what would be a really interesting conversation to have, and maybe some folks will chime in here on the call, is also, we firmly believe, the BMC's belief is that you shouldn't have to have data science skill sets and expertise in your IT shop to be, to run AIOps in your IT operations environment. But I'd be curious, I think it's an evolving space. I think there's so many different use cases and environments are so complex that it could very well evolve, that there's a mix of vendor-supplied solutions as well as homegrown solutions. But I'd be very interested to see how that evolves, even the next 6 to 9 to 12 months.
Yeah, absolutely. Let's have a look at the results. Okay, so it is similar, but more on the no, we are not there yet. So more responses around not having got to that point.
Okay, so that seems pretty fair. All right.
Yeah.
Well, what shall we wrap up and take questions?
Yeah, let's do a recap and a quick customer example and then move to questions.
Okay, so similar to our last webinar, just want to recap that our flow here in terms of implementation of analytics workflows and the evolution in your environment. We talked about 3 different types of machine learning algorithms: regression, classification, and clustering. So call those 1A, 1B, and 1C. That's the start. Getting that in place, you can also, it's kind of, maybe I should have said this is 1B, but automation is something that you can do in parallel with your machine learning approaches. But we talk about automation as a natural follow-on and a really critical part of AIOps. And then once you've established some wins and you've got some simple or direct first-order workflows working, you're going to expand by adding additional workflows and creating second-order workflows. And then finally, the evolution is to evolve your skill set and your organizational culture and structure to support that IT operator auditor role as opposed to the IT operator doer role.
Okay. For our customer example, we have a global trading banker, and they were really facing challenges similar to those that many IT ops organizations face. So excessive event noise and false alarms. They had roughly 1 million events per day coming in, and 98% of those were false alarms. So huge inefficiencies there. The alerts and events were based on static thresholds, and they lacked application and service level awareness. Also, they had long incident resolution process times. So those war rooms that Seth was referring to, they had long bridge calls with hundreds of, up to 100 people on the call trying to identify root cause and trying to identify how to resolve any particular event. They also had inefficient use of IT ops resources, and we hear this again and again. So too much time spent on non-priority issues, probably coming from all of those false alarms, lack of visibility, app dev teams were requesting monitoring on an ad hoc basis, and overall this really increased the mean time to identify and mean time to repair of events and incidents, and overall that led to outages and downtime. So the use cases that they implemented with the help of TrueSight AIOps was applying business level context to the end-to-end monitoring and event management process. Event suppression and blackouts combined with the dynamic baselining, so applying some of those regression and classification algorithms to dynamic baselining and event management helped to drive down event noise by 80%. And then on the incident resolution time, applying probable cause analysis as well as intelligent ticketing, so creating and routing incidents more intelligently from IT ops to the service desk helped to drive down incident management time of 67%. And overall, they had significant labor cost savings from applying automation, so using those deep insights from analytics to drive automation across the IT ops end-to-end process. So a good example there of identifying the problem, identifying the AIOps use case that can solve the problem, and then applying machine learning analytics and algorithms to that. So we have 5 minutes here, Seth, so I think a couple of questions we'll be able to answer. Some interesting ones have come through. So let me start off by asking you, here's a good one. When implementing AIOps, should the objective be to move from supervised to unsupervised machine learning as maturity progresses?
So, yeah, I think that's kind of a trick question, and it's a common misconception. So I would say, you don't really graduate from unsupervised to supervised. They're really different techniques that are used independently depending on the data, the type of data you have, and the problem you're trying to solve. So they're both valid. Now, in the case of supervised, the question is maybe you train the system once and then you set it off, and in a certain sense it becomes unsupervised because you don't retrain it. But in most cases, you're going to train the system, and then you'll probably have iterative training where it'll need to update itself. So the system will go through and retrain on the data to make sure that the algorithm is up to date. But that process it's really a description of the process of supervision as an approach, as opposed to are we actually actively watching it, do what it does, or is it doing something without our knowledge? It's two different techniques for different types of data and different problems.
Okay, great. Another good question here around automation versus analytics. What if our IT org is immature in both automation and applying machine learning and analytics? Should we get our automation house in order before we embark on AIOps?
Absolutely not. These are things that you should work on iteratively and in small chunks. So the point I tried to make in the automation section was automation can mean many different things depending on where in the value chain you're talking about and what sorts of business value you're trying to get out of it. And there are automation steps you can take that are completely independent of analytics and machine learning that are critical, I think, to success in IT operations. So anyway, I would just say that, just like I think you should bite off small chunks of machine learning and analytics workflows that you try to accomplish, I think also you should, bite off small automation chunks and try to work and build those out. And you can do those things in parallel. Immaturity is completely irrelevant.
Sure. Okay. And we had another question here around how you expect the algorithms for AIOps to evolve in the future and, new capabilities that will be within AIOps, but we may need to save that one. Actually, that would probably be a good webinar topic for the future.
Sure. I'd be happy to talk about that. I mean, I think at some point in the future or now, whichever you like.
Yeah, absolutely. Yeah, okay. Well, yeah, why don't you just touch on that for a minute before we wrap up?
Sure. So, I think the next big step is what's called neural networks. I think that to demystify it, it's still a way of applying classification and clustering kind of techniques. really what we're seeing is the evolution of the application of those same three fundamental techniques, just with new types of technology. So as our systems get better, we increase our capability for doing computational, algorithms in real time. And as we improve our ability to manage new and complex sources of data, then we're going to come up with more refined and sophisticated ways of trying to implement the algorithms. Everything we do falls in a pretty simple bucket. It's just there's 7 different ways you can do regression. There's 10, 15, 20 different ways you can do classification and clustering. And which way you do it, which direction you choose or how you do it, it will determine how effective your application is in any particular instance. So in some cases, one approach might make more sense than another. It may fit the data better. It may fit the environment better. Part of our job as a vendor in BMC is to pre-test that. So the algorithms that we select are the algorithms that we know work well for IT operations, because we've been doing IT operations for 30 years. We know what the data looks like. We know what customers experience. So the algorithms we pick are based on our domain knowledge, right? Now, there may be new algorithms created in the future which are better, in which case you'll see an evolution in that direction, and that's what some of the things like neural networks and those sorts of things promise.
Yeah. Okay, great. Thank you, Seth, for your insights today. And I would just like to encourage viewers to sign up to attend the next webinar, which will dig more into automated operations as part of an effective AIOps strategy. That's on September 26th, 11 a.m. U.S. Central Time. There's a link there in the resources section to sign up for that next webinar. I hope you found the content today useful. Thank you for joining, and we look forward to welcoming you to another webinar again soon. Thank you, Seth.
Thank you, Monica. Thanks, everybody, for attending.